on top of line 1. Kind of, well, could you imagine line 2 on top of line 1? What do you guys think that means? If you put line 2 over line 1, you see this beta? Isn't that the same as what? This angle, if this line goes on top over here, isn't that also beta? Similarly, if this is alpha, isn't this what? Alpha, by putting line 2 on top of line 1? And then what do you guys notice about this? These are vertical or opposite. This is what? Alpha. And then what is this? Beta. So what are you guys looking at right here? I mean, we could have even looked at this right here too. You didn't have to look at that top. We could look at this. What do these three angles form together? Alpha, gamma, beta. Alpha, gamma, beta. If I add these, what angle does this form? A straight line, which measures 180. Is that true? So the sum of these three angles equals what? 180. The sum of these three angles is 180. In fact, the sum of these three angles, we could do this all day long. This forms a straight line too. So does this over here. Doesn't even matter. The point is alpha plus beta plus gamma is what? 180, or a straight line. So this is kind of a derivation here, or a demonstration of why the sum of the interior angles for any triangle is really what? 180 degrees. Okay? So you do want to remember this concept because it's actually something that people kind of test you on in a lot of settings. So anyway, can I erase this stuff here? Can I erase everything on the board? We could kind of get to work on our word problems. Did you have a phone? I can erase this. Should take a picture. Yeah.
Didn't you teach this in 110?
Yes, I did. Yes, I did. That's certainly true. Did you guys see this before?
Same notebook.
Ah, there you good. Good. Did you check? So do you cover this in Math 110? No, you didn't. Did you take 110? Who'd you have? Oh, throwing the cameras on. Tell me later. Okay, yes, we do talk about it in 110. Mr. Judge's class talked about it in what? 110, that's true. All right, good. Well, you may say, all right, I'm glad you remember, because in Algebra 115, guess what's going on? They're going to have us work with some number problems in the setting of some geometry, concepts here. So let's take a look. Let's look at this is a nice problem. I love number 11. Did you guys like number 11? Did you see what it was? On the worksheet. Good. Anybody look at that stuff? Yeah. Good. Okay, let's go. Let's do this stuff. Let's take a look. It says the second angle of a triangle is 3 times the first. The third angle is 60 degrees more than the first. Find the measure of the smallest angle. So to give you guys a few seconds to write that down, that's actually number 11 on the worksheet. Okay, and I'm going to say a few things. Should we leave that up, or should we get rid of it? Did you get all this? Not yet, huh? Okay. It's all right. All right, what kind of setting are we talking about here? You read this? How many times do you have to read this? Huh? Enough. Good. Have you read it enough times? I don't know. Let's see. What's the setting? What do you guys know?
The angle is 3 times the first.
Oh, I think I didn't write it down.
Triangle.
Triangle.
Second angle of a triangle.
Oh, the second angle. That's okay. No wonder. Of a what? Triangle. I think that's an important detail, don't you think? So what setting are we in? Triangle setting. Good. We're in that setting. Okay, fine. What are they saying? Let's use the language. Let's read the first sentence. Doesn't it say that what? The second what? Angle. In other words, the second angle, what does this is mean? Equals what? 3 times. Isn't that 3? Isn't that times? Times what? The first. So I'm going to say second equals 3 times the what? The first. You okay with that? That's the meaning of that first sentence. That's the literal meaning of it. And then what does the second sentence say? The third angle is, what does is mean again? Equal, good. So we're going to say the third what? Equals. Now, did you guys learn those phrases? What comes after this is? 60 degrees, what? More than. So the phrase was triangle more than my what? Square or rectangle. What does more than mean? You do what? You add? Okay, good. What are you adding? What does the more than situation do? I know it's addition, but what are you doing?
You switch it?
You switch it. That's right. What's in the triangle? 60. What's in this rectangle? The first. You guys okay with that? You guys with me on that? All right, whatever. Okay. Messed up, sorry. All right, here we go. Okay? So this is what it means. First plus what? 60. Okay, you guys okay with that? Now, you did get all this now too, right? Okay, good. You really want to amaze your friends and frighten your enemies, right? Here we go. They said alpha, beta, gamma, right? Which one is the first? Which one's the second? Which one's the third?
I'll say alpha.
Well, you don't really know, but you can say that, right? Okay. So here's my triangle. And I'm going to say what? Maybe first, second, and what? Third. And so you say, well, what are you talking about? Well, that's the language they gave us in terms of these angles. What that means is the first angle plus the what? Second angle plus the third angle. What should that equal? 180 degrees. Okay, you guys with me on this so far? Yeah, they call it alpha, beta, gamma. But they also call it first, second, third. So here's what you're going to do. This is algebra. So what this means is we're going to have to use a variable to represent a quantity here. Okay, we're going to use the variable x. So we're going to let x be. Now here's what I want to say to you. Let the variable x be a convenient angle for you. And you say, what do you mean it has to be convenient? It has to be convenient. What do I mean by that? Look at this. Look at these phrases here. What should x be? It's going to be either the first, the second, or the third angle. What should it be?
The first.
Why do you want x to be the first? Because it's what? Convenient. Is that right? Let's see how it's convenient. Let x be the first angle. This is why it's convenient. Who can tell me then what's going on? If x is the first angle, what's the second angle? 3x. Then 3x is the what? Second angle. And what's the story? X plus 6, or x plus 60 is the what? Third angle. So do you guys see when I say let x be a convenient angle here, a convenient quantity? Because the second is described in terms of the first, and the third is described in terms of the first. So that's a nice thing to say, is that right? That makes everything fit nicely. Okay, good. Now what does this mean? Well, what's the first again? X. What's the second? 3x. What's the third? X plus 60. And we know that the sum better be what? 180. Okay? So now guess what you guys get to do? Use some algebra. So on a test, I'd give you credit and go, okay, good, you're using the algebra principles. You translated this correctly. Solve for x. And when we do, we have to combine like terms here. So we get x, 3x, and x give you what? That's 5x now plus 60 is 180. Translate your what? 60. And you end up getting 5x is 180 minus the 60. What does that mean? 5x is what? Good. 5x is 120. Divide both sides now by what? 5. What do you got? What is x? Is x 24? Okay, good. X is 24. 24 degrees. Is that true? So that means that, what does x represent? First. So this is 24 degrees. Is that right? Now, what's the second? The second is 3 times the first. What's 3 times 24? Isn't this x 24? It's the same x. What's 3 times 24? 72 degrees. Good. And then this is the same x at 24. What's 24 plus 60? 84 degrees. Good. So, first is 24 degrees. The second is what? 72 degrees. What's the third? 84 degrees. Who can tell me what was the question? Find the smallest angle. So now you'd have to determine which one is the what? Is the smallest. Which angle should be the smallest? Well, the smallest value, right? It's the what? 24. This was what number is this? Number 11. Yes?
When we take our test, do we have to find all of the angles?
You know what? I would, if I were you, I would find all the angles. You know why?
Just to make sure your answer.
Well, because it might be, we really don't know what these phrases are going to be. So, when you say you got to think critically about this, you don't know what these phrases are going to be. So find all the angles, and then deduce which is the what? Smallest. Is that kind of a good game plan? Because they could say to you, what's the middle angle, or the angle that's right in the middle, or what's the largest angle? You may not necessarily know what it is based on the information you have here. So you're going to have to get all the what? The values. Okay, you guys okay with this one? Is this one easy or hard? That's hard. But notice this. How have we been doing this? What have we been talking about? We have what? The language. Yeah. The language. What else? The geometry facts. And now we put it all what? Together. You're solving an equation. And this is pretty significant now. Okay, you guys have a lot of things going on with that. But it isn't impossible. It's actually what? Doable. No what for you this weekend? No what? No beach. It's going to be probably cold at the beach now. How hot's it going to be today? Do you guys feel how nice it is now? Don't you feel like a human being again? Oh, I feel so good now.
It's going to get warmer.
It's going to get warmer?
Yeah, that's what he said.
Oh, really? Okay. You going to take a picture? You got to hurry because I'm about to erase this. I want to go to do another problem. It's going to be hot? Well, I could go to the beach. I'll be at the beach.
I'm going to take a picture of this.
Well, you guys better hurry. So I'll be at the beach, and you guys will be doing what? Some homework, because that's how it works. And then when you're done with your homework, what do you got to do? Then you got to go to the beach too.
This is just later.
You've been in the picture.
All right, let's erase this here. All right, let's look at let's do some more problems here. Okay. Let's look at should we do an easy one? Let's do an easy one. We're on 13. Two angles of a triangle. Look at this. Two angles of a triangle. Are 40 degrees and what? 30 degrees. Oh, this one's easy. What is the measure of what? Of the third angle. Huh? How did you do that so fast?
Because it's a triangle.
Okay, good. What do you guys know? If it's a triangle, so what's the story? I guess what kind of language are they using? First, second, and third again? Oh, is that right? So I guess the first angle plus the second angle plus the third angle better be what? 180. What did they give me? Well, I don't know. Oh, they said, what's the third angle? I don't know. I guess that means this is the first and this is the what? Second. Does that make any sense? They didn't say it though. Yes. But it doesn't really what? Matter. See this critical thinking? Yes.
When it's a triangle, is it automatically 180?
Yes, it is. We just proved it. Yep. So this is 40. Call that the first. This is a what? 30. Call this the first. Call this the second. Does that kind of, oh, what should we say? Does that make the most sense? Okay. And so in some ways, you can say now what? 40 plus 30 is what? 70. So 70 plus the what? Third angle is 180. Hey, this is algebra. Is that true? We don't solve for words, do we? We solve for what? Letters. So call this x. So sometimes they say, let x be the what? Let x be the third angle. If x is the third angle, then we can now solve for the letter by simply doing what? Translate your 70 And you get what? X equals 180 minus 70. What's 180 minus 70? So, okay, so you're right, it is 110. Or simply the third angle is what? 110. So you use the geometry fact that the sum of the interior angles of any triangle is 180. Okay, so you guys use that. Okay, let me do a couple of things for you guys here, really quick.
Can't see the phone.
All right, let's look at number 14. Let's look at number 14. We got to talk a little bit about 14 here. Some interesting information. 14 says this. Before we do that one, let me do a note here for you. This is supposed to measure a right angle. And if I say to you that you have some angle here called what? Some angle, let's call this angle alpha. And alpha measures what? 20 degrees. So call this alpha, which measures what? 20 degrees. So I can say alpha is 20 degrees. Okay? The neighbor, or the adjacent angle, do you guys know what we call that? Earlier we called that what angle? Beta. We can still call it beta. But if I said to you, what is the measure of beta? Well, let's go through this. What do you know? You know, and this is a question, what does beta measure? Well, let's see. Alpha plus beta is what? 90 degrees. What's alpha? Is that 20 degrees? Is that true? So you can say that beta then is 90 minus what? 20 degrees, or beta is 70 degrees. Is that true? Okay, so this is 70 degrees. Notice, isn't 20 plus 70 90? Okay, what do you guys know about these angles? They're certainly adjacent. What else are they? They're complementary. So you can say that alpha and beta are complementary. Okay, so that's a specific example of complementary angles. But we can also do this. Let's pretend for a second that we don't even know the value of alpha. It's not 20. It's some number in general. So that means that the complementary or the complement can't be 70. How about if I say this to you? If this is alpha, I'm going to ask you the same question. What's the measure of beta? But notice this is now done in general because you don't know an alpha value. Can I describe beta in any way? Good. How do you know you can? You don't know the value. Do you guys remember that worksheet called formulas? And they said you to solve for the indicated variable? Do you guys remember that worksheet? It's kind of back. Could you guys solve for beta? How? Translate. Good. Translate what? Good. What that means is beta is 90 degrees. Alpha on the left has a positive sign, right? Or has no sign at all. What's it going to be on the right? Negative. Good. So what I'm saying to you is sometimes they describe this as 90 degrees minus alpha. In other words, they sometimes say alpha and 90 degrees minus alpha are complements. Okay? So you may say, well, what is that? What's going on with this now? Well, let's look at this number 14. The complement of an angle measures 78 degrees. Less than the angle. What is the measure of the angle? Okay, so let's write this down. What do you guys see? What does it say? Complement. Is that right? We got complement of an angle measures. What do you think that means? The word, yes. The word measure. That's not is. That's not equals. I mean, it's not the word equals. That's not is the same as. But what do you think they're saying? The complement measures. The complement what? Is. What is the complement? So this word here means equals in this context. And what do you guys see? 78 degrees less than what? Triangle, the angle. So the complement equals 78 degrees less than the angle. Is this a less than scenario? Do you guys, what do you do with the less than? Switch, good. So it's going to be the rectangle. Now less than is what? Subtraction of what? 78. So I have your angle here. What else do I have? 78 here. You guys okay with this? Okay. What do you guys think? What should x be? What do we deal with x? What do you guys know? How about if I draw this again? Let me make sure for you. It's complement, right? So let's call this angle. And what would we call this? Angle, and it's what? Angle, and it's complement. Good. See this? Alpha, 90 minus alpha. Angle, and what? Complement. So what does this mean? Angle plus the what? Complement better equal 90. What do we want to call angle? X. Good. Call this X. If angle is X, what's the complement? 90 minus what? 78. Okay, so you're going to let this angle be our variable x, because this is algebra. What that now means is my complement is x minus, the angle be x. What's the complement? X minus what? 78. So let this be x, call that angle x, complement x minus 78. So you're going to call this thing x for angle. This now becomes x minus 78 what happens when you add these? It better be what? 90. So you get an equation that's x plus x minus 78 equals what? 90. What happens now? 2x minus 78 is 90. Translate the what? 78. 2x is what? 90 plus 78. What does 2x measure? What's 90 plus 78? 168. Divide both sides by 2. What do you get for x? X is what? Is it 94? 84 degrees. What did they ask for? Find the measure of what? The angle. Okay. Well, what do we let the angle be? X. Did we solve for x? So we answered the question. This is the what? The angle. Yes? Why do we see two x's?
Yeah.
You're going to let x be angle?
Oh, the complement is x minus 78.
Exactly. And what happens when you add an angle with its complement? It's 90. Yeah, so if this was 30, this would be 60. So if the angle is 30, the complement is 60. If this is 10, the complement is 80. This is 15, the complement's, what's 90 minus 15? Is that 75? So it'll be 15 and 75. The angle's 15, the complement's 75. What happens is when you add the angle with its complement, it's 90 degrees. Okay, so they changed some of the language a little bit on you, but it's not that big of a deal. We just always know an angle and its complement, sum is 90. An angle and its supplement, the sum is what? 180. You guys okay with that? Let me give you an example in number 16. Find the measures of the supplementary angles. Here's what they gave you. What did they give you? Okay, 9z and 7z. Determine the measures of the supplementary angles. What do you guys know? Well, what do you do with these two? What are they asking for? They're saying, what do both of these actually measure? These are supplementary angles. They're next to each other and they form a what? Straight line. So what does that mean? 9z, since they're supplementary, 9z and what? Plus 7z, what does that equal? 180 degrees. What's 9z plus 7z? 16z is 180 degrees. Can you guys solve for z? Okay. What does z give you? What's 180 divided by 16? Is that 5? Huh? Is it 15? What would you do? Do you reach for your calculator? No. 16 goes into 18 how many times? Well, 1 times 16 is 16. Subtract. You got what? 2. Bring down to what? 0. 16 goes into 20 how many times? 1. 1 times 16 is what? 16. Subtract. You got what? 4. Uh-oh. Decimal. Bring down to 0. 16 goes into 40 how many times? 2. 2 times 16 is 32. Subtract, you got 8. Bring down another what? 0. 16 goes into 80 how many times? 5. Good. 5 times 16 is 80. Subtract. You got 0. What is Z? 11 point what? 25. What do you do with that value of Z of 11.25? Put it back in here. 11 point what? 25. Put it back here. 11.25. What do you get for the angles? What's 9 times 11.25? And then what's 7 times 11.25? What does that arithmetic give you? 9 times 11.25? What do you guys got? Is this, what's this one? Is that 101.25? What's the next one? What's 7 times 11.25? 78.75. Is that true? What should you do to verify this? Add what? Add these two. What should it be? Should it be 180? Say yes. When you add these two, that should equal what? 180, does it?
Yes.
Okay. So these are the angles. Okay, anybody have any questions on this?
When you add 11.25 and 78.75 is 180?
Yes, it is. Is it true, though? Did you add it?
No, I didn't.
Okay, 180. Okay, let's look at number 17 here. Okay, so what shape are we talking about here? You have a rectangle, is that true? So you have a rectangular lot. Okay. So we're going to draw a rectangle here. So here's a rectangle. I'm going to finish off this word problem worksheet. Okay. So what do you guys know about a rectangle? Anybody know the longest side is called the what? The length. The shortest side is called the what? The width. Okay. We designate this sometimes by the letter L, by the letter W. What do they know? They're also talking about a perimeter. Right? So what's the perimeter of a rectangle? How do we describe the perimeter? Isn't good. 2 times the length plus 2 times the width. Are you guys okay with that? Okay, now let's take a look at the statement. Let's see what it says. They want us to find the length of a rectangle, so we're going to have to determine L. So we're going to have to say, what is L? They want us to find the length if the perimeter is what? 70 meters. So when they tell you that the perimeter is 70, they mean this thing equals what? 70. Good. So this is going to be the value 70. Okay? Because they say the perimeter here is 70. Okay? So that's what this information means. And then we're going to read the statement, and the statement says what? If the length is what? 7 meters more than the width. So what are they saying here if they say length is? Do you guys know? What does that mean? Good. They mean that the length, okay, the length virtually what? Equals This is 7 meters more than the width. So I see a triangle more than a what? Square here. Okay? So you're going to say 7 more than, I know that's addition. Then my width comes first. Width plus what number? 7. So I know my perimeter is 70. This equation is 70. The length is width plus 7, because this is what the phrase says. Now this is an algebra class, right? So what should I do with all of this information? What do you guys think? How do I work with this information? I have this information. I also have what? Let's work with this. 2L plus 2W equals the value 70. So we can clear off some board space here because the perimeter is 70. Okay, so what do you guys want to let X be again? We want to let X be something very convenient for us. What should we let X be? Good, W. Why let X be W? That's a good choice.
Once you find W, you have the other answers.
That's right. Let X be the width. Okay, so you're going to let X be the width. And if X is the width, you guys are going to say that right here. X is the width, right? X is the width, here and here. Then what is the length? X plus what? 7. Good. So then we can say X plus 7 is the length. So that's pretty good. Okay, so here we go. Then we're going to replace this length with X plus 7. So let's see what this equation gives us then. We got 2 times the length, which is really X plus 7, right? So that means we get 2 times that X plus 7 here, plus 2X. And that's supposed to be the value, what? 70. So here's an equation that we're going to have to solve. This is the equation. So on your test, if you did this, if you created this equation, you would get a check mark because you did everything correct. Okay? Because they're describing here, length is 7 meters more than the width, which is going to be width plus 7. If we let X be the width, okay, the X is the width down here too. We get a nice linear equation that we can solve. How do you guys solve this? Right? You got to simplify the left side. So we're going to use the distributive property here for the equation. And you now get 2x plus 14 plus 2x is 70. You get what? 4x plus 14 equals 70. Translate the 14. Okay, move that 14 over here. So you get what? 4x is 70 minus 14, or you get 4x is, what's 70 minus 14? Is that 56? Divide both sides by that 4. What is x? What do you get for x? X is what? 16, is that right? I think x is 16, is that true? Is 56 divided by 4 16? No? I don't know, I'm not even awake yet. Is it? 14? See, 4 goes into 5 once. You got 16. I think, see, you're right. It's 14. Not even awake. All right, so the width is 14. Go back here. Your width is 14. This is what x is. And what's the length? It's 14 plus what? 7. What's 14 plus 7? 21. So ladies and gentlemen, what do they ask us for? Do they ask us for the dimensions of the rectangle? What do they ask us for? What is the what? Length. So right here, L. All right, good. You guys are okay with that. Is that right? You got the length. Okay, everybody okay with this one? Anybody have any questions on this one? You sure? Is that one easy? That was pretty easy. All right, what about this next one? Okay, we got a lake here that's in the form of a what? Of a triangle. Is that true? Can I erase this mess here so we can use this board space? Okay. All right, so take a look at that. All right, what does this say? We got a triangular lake front lot that has a perimeter of 2,200 feet. One side is 300 feet longer than the shortest side, while the third side is 400 feet longer than the shortest side. What is the lengths of the sides? So let's do this. Let's draw a triangle. Okay, you guys okay with that? I'm going to draw a triangle over here. Okay, so here's some triangle. What do they tell us about this triangle? It also has a what? Has a perimeter, is that right? What's the perimeter value? 2,200 feet? Okay, is that right? So I'm going to say to you guys automatically that the perimeter equals what? 2,200 feet? Okay, you okay with that? What's the definition of a perimeter, though? What do you guys know? What's a perimeter? Isn't that the distance, what? Around? Is that right? Okay. So here's what I'm going to do here. Here's the problem, though. For a triangle, we don't generally have nice sort of quantities that represent things like the length and the width for a rectangle. You guys know what I'm saying? For a rectangle, you got a length and a width. For a square, you got a side. But for a triangle, we actually have three sides. So sometimes they will say, let the length of this side be A, let this one be B, and let this one be C. In other words, what we're saying is that A plus B plus C, this represents my perimeter value. This is the perimeter. That better be what value? 2,200 feet, because this is the what? This is P for my perimeter. You guys okay with that? You guys okay with this thing here? This thing is P. The perimeter is A plus B plus C, which is going to be that 2,200 feet. So that represents your perimeter, so you guys know. Okay? So that might be useful for us because what are they saying? Look at the language. They said one side is 300 feet longer than the shortest side. So we got this information, something called one side, and that is, so let's write this down. One side is what? 300 feet longer than the shortest side. What do you think longer than the shortest side can mean? What is this? What about this longer than the shortest side? What does it mean to be longer? Huh? If it's longer. One side is longer. What do you think I could replace that phrase with, longer than? Good, thank you. More than. Isn't that longer than? More than? So they're saying 300 feet, what? 300 feet more than the shortest side. Good, you guys are good with that. So 300 feet more than the shortest side. I'll just put 300 more than shortest side. Okay, and then what do they say? The third side is, what do you guys know? The third side is 400 feet longer than the shortest side. So I'm going to call this one third side is now 400. They have that phrase again, longer than. You guys are correct if you said replace that with what? more than, so we say that it's 400 feet more than what? The shortest side as well. Whew. Okay, and now they say, what is the length of each side? So, these are the phrases that we're using. I know up here, let's put all this information. We know up here that the perimeter being 2,200 feet really means A plus B plus C, the sum of the sides, is 2,200. Here's the thing though, we have to translate these things, right? Let's translate this. One side is 300 feet more than, so I have this thing called what? One side, and it equals triangle more than my rectangle. So if I translate that, I'm going to put that maybe right here. Let's say one side equals what? Shortest side. And that more than represents addition, right? So that's plus 300. And then I have this other thing called the third side. And that represents, again also, third side is, we have our equal, triangle, more than my rectangle. So we also have the shortest side. And we're going to add the 400, is that right? So we translated these things, okay? Now let's use some algebra. Okay, we're going to do some algebra. What do you guys want to let x be? What should x be? Good. We have to let x be what's convenient here. Is that right? So if I let x be the shortest side, here's what we're going to write down. Let x be the shortest side. If x is the shortest side, then what do you guys know? One side is really what? X plus 300 is one side, and x plus what? 400, that is the third side. Is that true? So it looks to me like you got something called one side, something called third side, something called shortest side. Is that three sides? All right, which one is which? Do you guys know? Well, in this picture, what would you call the shortest side in the picture? A. We called that one x, right? So this will be what? X. This is x. Now we have a what? One side and third side. Which is one side and which one's third side? It doesn't really matter. We can call B what? One side, and then C what? The third, because maybe A, B, C. That kind of makes some sense. So then one side, this is going to be x plus what? X plus 300, and then this is x plus what? 400. So we got an x plus 300, and here an x plus what? 400. Okay, you guys okay with this? All right, is that scary? No, is that kind of scary? Yeah, can I erase this? You guys have that in your notes? Okay. Okay, anybody have any questions so far? Okay, this is the setup we use in algebra. So what kind of equation do you guys see here now? What do you got? You got what? X plus what? X plus 300 plus, what's this? X plus 400, and what does that equal? 2,200, right? Here's the equation. If we solve for x, we got the length of each side. So we got x, x, and x. How many x's is that? 3x. We got 300 and 400. That's 700. And what does that equal? 2200. Right? And then what do? Translate your 700. Okay, and you get what? 3x is 2200 minus what? 700. Our 3x is, what's 2200 minus 700? Is that 1500? Okay, divide both sides by 3. What do you get for x? X is 500? Okay. Now they asked us in the original question, they asked us for the length of each side. I found x, which is the length of what? The shortest side. Okay. So the shortest side here is 500, by the way. Okay, this was 500. Now, how do we get this next side? Add 300. What's 500 plus 300? So this one is 800. Good. And then this last one is 500 plus what? And what does that give you? 900. So, ladies and gentlemen, and this is all in feet. You got 500 feet, 800 feet, and what? 900 feet, all from the fact that x is 500 feet. Yes?
So how do you write that in an answer? You just put like shortest side equals 500?
Well, you could, yeah, what you could do is say 500 feet, by the way, over here is the what? Shortest side. 800 feet is the one side. So you could go back here and say this is 800 feet. 900 feet is the what? Third side. So essentially what you guys see here and what you see here circled is the answer, because they wanted you to just find the lengths. Okay, so you got the lengths here. And then you're done. All right, you okay with that? All right, is that pretty simple? What do you guys think? Is that pretty simple? Is that simple stuff? No? What's so hard about that one? Let's see what you have to say. What's hard about that one? Huh?
Probably the language.
The language portion? Okay, here we go. We're going to work on these three problems here. First of all, I want to note a couple of things here. Let's give you guys some notes that for the supplement situation, let's write it this way. Okay, you have an angle. If we have some angle called x, let's call that our angle. We can describe the supplement of that angle simply as 180 minus x. This is what's called the supplement of the angle. Okay, we can also, for the angle x, describe the complement of the angle as 90 minus x. So here's the complement. Okay, so this is the same angle. So if we have x, 90 minus x is its complement. The angle x again, 180 minus x is its what? Supplement. Okay, you guys okay with this? So this is 15 on the worksheet. And let's see what they say to us. What do they say? They say that the supplement of an angle measures 28 degrees more than twice its complement. What is the angle? Okay? Here we go. How do you describe the supplement of an angle? 180 minus x. Good. So the supplement here, we're talking 180 minus x. And then they're saying this thing measures. This measures, that means this equals triangle more than what? That rectangle, I guess. Okay, so far, if I had to write an equation, the equation looks like this. The supplement, or let's write it this way. Let's do every detail. Okay, the supplement measures, or the supplement equals what? Triangle more than what? More than rectangle? How do you guys describe that? Rectangle plus what? Triangle. Well, what's in the triangle? 28. Now, what's in the rectangle? Twice. Twice. Twice means, what does twice mean? 2 times what? The complement. What's the complement? 90 minus x. Good. So you don't just put 90. That's not the complement. 90 minus x is the complement. So you're going to put in here 2 now times that 90 minus the x. Okay, and then you replace supplement again with what? This is the 180 minus x. Okay, so let me erase this form here of the language of the more than. Okay, so we get 28 there. Don't forget twice, 2 times the 90 minus x. Okay, so supplement we replace with 180 minus x. Two times 90 minus x. Okay, so if you created this equation, ladies and gentlemen, you're on your way. This is what I'm looking for on a test. That equation. Okay, and then what do you need to do with this equation? Solve for x. So on the right, you can simplify by the distributive property. Okay, so you get 180 minus x becomes, what's 2 times 90? That's 180 minus 2x plus 28. So I just use the distributive property here to get rid of my parentheses. Okay, you okay with that? Now, what do? Translate the what? I do a double translation. I'm going to translate my 2x. I'm going to translate my 180. And if I do that, notice what I get as an equation over here. That 2x on the right is negative. It's now going to be on the left what? Positive. So I'll put the 2x here. Don't forget my minus x is still here on the left. On the right, I have a 180. I have a plus 28. These two terms are here. I'm just moving my 180 on the left, that's positive. On the right, it'll be negative. Minus the 180. So if we take a look at this, what's 2x minus x? X. Notice the 180 minus 180 is gone, right? So x is what? 28. What was x anyway? X was called the what? The angle. They want to know, what is the angle? You just found it. It was 28. 28 is the angle. Okay, you guys okay with this? Take a look at this. This is all the information you guys need to do number 15 on the worksheet. Okay, anybody have any questions on this one? No, you're okay with that? All right, I'm going to erase. Well, let me actually start to write things down here. Let's take a look at this. We have a square plywood platform has a perimeter which is 6 times the length of a side decreased by 10. So, what's the geometric shape they're talking about here? They're talking about a square. You okay with that? What does a square look like? Okay. Do you guys know this is what a square looks like right here if I put it here for you? Is that kind of a square? So it look more like a rectangle. Look like a square? It's pretty good? Okay. Do you guys know something interesting about a square? What? All sides are the same. So call this S. It's not a 5. This is an S. This is an S. This is an S. This represents side. Is that right? It's not 5, it's S. Now, what do they say? The perimeter. Do you guys know what a perimeter of a square actually is? It's the sum of the sides. So, the perimeter is what? S, 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 S. You're right, it's 4S. By the way, just to point out to you guys, the perimeter is 4S. Now, what are they saying? They're also saying that my perimeter, okay, is, so here's perimeter. Perimeter is, that's equal. Is that true? Perimeter equals. Let's see what this perimeter equals. The perimeter equals what? What does it say? It is 6 times what? The length. How do you guys write 6 times? What's the length of a rectangle anyway? Or sorry, of a square? What's it called? S. So this is 6 times what? S. So you have to put 6 times what? S, and it is what? Decrease. If I said I'm going to decrease your salary, what am I doing? Subtracting. I'm going to decrease your allowance. So I'm going to subtract. How much am I subtracting? How much am I taking off this week? $10. So it's decreased by 10. Okay, I want to point this out. This is my 6. This is my S. Right here. 6 times. That's multiplication. Decrease is minus. And that's the amount. So we have the perimeter, our P. Let me rewrite this. P is 6S minus 10. And so let me go through some logic with you guys. Okay. If P is 4S, I'll put all the logic here. Here's P, 6S minus 10. Tell me what you guys think about this. Well, let's double check. Let's see. Right? If P is 4S and P is also 6S minus 10, what do you think that means? These two pieces of information together. P is the same quantity. So P is 4S, P is what? 6S minus 10. What does that mean? These two things together. What do these imply? Well, what if I told you Jennifer Lopez is J-Lo? And I also said Jennifer Lopez is Jenny from the block. That's the same logic. You guys can do this. Jennifer Lopez is who? J-Lo. Jennifer Lopez is also what? Jenny from the block. What do you guys? What's the conclusion? J-Lo is who? Jenny from the block. In other words, 4S is, what's 4S? 6S minus 10. You okay with this? All right, you guys okay with this? What do they want to know? Find the length of the side. That means what is S? You guys have an equation in terms of S. So solve this equation for S. I do a double translation personally. And so I end up getting 10 is 6S minus 4S. You guys need this in red? You guys okay with translation? You want it in red, or you okay with that still? You guys can do this now. 10, we change the sign, it's now positive. I didn't move my 6S, so I'm going to keep it blue. I moved my 4S, so what color is that now? That's minus what? 4S on the left, plus 4S on the right, minus 4S. 10 equals 2S. Divide both sides by 2. What is S going to be? 5. So is this in feet? I don't know. I don't think they gave us any units. So it's 5 units, I guess, is S. Happens to be the number 5. Okay, you guys okay with that one? S is 5.
Yeah.
6S minus 4S gives you what? 2S. Okay, anybody have any questions on this? You sure there's no questions? Yes.
So basically when it says twice the complement means that you have to write it in parentheses.
Well, let's go back. The question was on what? On this one. You have any questions on the one we just did? Nobody has questions on the one that we just did? No, but you have a question on the prior one then. Okay, what's your question?
Then when it says twice its complement, do you have to write in parentheses?
Yes. You know why? Because the complement, ladies and gentlemen, isn't just the number 90. The complement of an angle is what you see here. It's 90 minus x. It's an expression. The expression is 90 minus x. So when they want it to be twice the complement, it is 2 times the 90 minus x, because 90 minus x is the complement. So yeah, you got to multiply it by 2. In other words, if it's not just a single term, if it's more than one term, you're going to need to put your parentheses in general. Because that's the whole complement. It's 90 minus x. Don't just put 90. Okay, the complement of an angle is not 90. If I told you, what's the complement of 20 degrees? If this is 20 degrees, what would the complement of 20 degrees be? Not 90. Some guys go, oh, I know, 90. No. If the angle's 20, you have to tell me what 90 minus 20 is. What is 90 minus 20? 70 degrees. The complement will be 70 degrees. So don't only look at the complement as being one component. It's 90 minus the angle. Okay, you guys okay with this? Simple stuff, right? Simple what? Simple.